guys, today we're going to go through this 6-mark A-level chemistry question. Now this is from paper 1, so this is the physical and inorganic chemistry paper from June 2019. So let's go through this. Now this question has a lot of information, so I won't read through all of it, you can read it yourself, but we have to calculate the percentage of copper by mass in the alloy. And it's to do, and we're using this sodium thiosulfate titration and our knowledge from that. I'll give you some time to read through all this, and I'm going to talk about how you will go through this question. Now, they've given us a lot of information, all the steps that they've taken to carry out these two titrations, and we're essentially going to be working backwards with the information that we have. So let's get started. So let's look at this last bullet point. There's they use exactly 9 centimeters cubed of 0.08 moles per decimeter cubed of sodium thiosulfate solution to react with all the iodine produced. So we can use our equation, which is moles is concentration times volume, and find the moles of sodium thiosulfate. That is for this reaction. So I'll write it like this. And it's going to be 9 times 10 to the minus 3 because they've given it cubed. And we need to remember that we use decimeters. Times 0.08, and that should give us 7.20 times 10. That is 1 mark we have achieved. And now let's step back. So we have this sodium thiosulfate that reacted with all of this iodine, but this iodine essentially came from this reaction, didn't it? Where they added an excess of potassium iodide. Now we're trying to find the percentage of copper by mass in the alloy, and it's in this reaction where we can see the copper. Now, if we use our ratios and look back at this, for every 2 moles of sodium thiosulfate, it reacted with 1 mole of iodine, and 1 mole of iodine was produced here as well. So 2 moles of copper iodide and 1 iodine. So the ratio doesn't change for iodine, and therefore when we're looking at the copper, it's 2 and 2. So when we're looking at the moles of copper in this 25 centimeters cubed of solution, it's going to be the same as the moles of sodium thiosulfate that we have just copied, because the ratio has not changed. So we're going to write it like this. 25 3 7.0. Make sure to show this clearly, even if you know it in your head. So that's our 2nd mark. But yes, I wrote it here. This is the moles of copper 2 plus in 25 centimeters cubed. But when we look back, so we're going to ignore this 3rd bullet point. When we look back, this 25 centimeters cubed is taken from this 250 centimeters cubed of solution. Therefore, the moles of copper 2 plus in 250 centimeters cubed is going to be different, and it's just going to be 10 times more. 250 is 10 times more than 25. So that would just be 7.20 times 10 to the minus 3. That is our 3rd mark. Now, we figured out the moles of copper in this, and so now we know how many moles of copper was in this mass of alloy, so we can also figure out the mass of the copper that was in the alloy using the moles that we calculated as well as the formula mass. So we would do 7.203 times math, the formula maths, which is 65, and we should get 0.457 grams. So that is our. Now, the fifth mark we can get by either converting the grams into milligrams or converting the milligrams into grams, because we were given the mass of the alloy in milligrams. I'm going to convert it into grams. So that is just 0.985 mg is equal, 985 mg is equal to 0.98 grams. And then, so that's our fifth mark. And our sixth mark will be to calculate this final percentage copper by mass. So I'll write this here. Oops, now we're going to do using our knowledge times 100, and the answer I get is 46.395. But in the question it says, give your answer to an appropriate number of significant figures. Now, when we look back on this question, the lowest number of significant figures that we're given is 3. So 985, that's 3. 250 here is 3. 25.0 here is 3. 9.00 is 3. So we're just going to give it to 3 significant figures, which should be 46.4. That is how you would do this question. It's very long-winded and there's lots of steps to it. But as long as you work backwards and you're not intimidated by it just by looking at it, everything should be fine.